In this video, we're going to talk about how to create graphs that are appropriate for a scientific context. The fact is that there are as many ways to create a good graph as there are contexts in which that graph might be used. For example, if you wanted to create a scatter plot of some data, the best way to do so might depend whether that scatter plot is intended to be published in a newspaper that's read by a wide public audience, or in a scientific paper with a much narrower audience and a particular focus. In scientific communications, there are some particular things that we prioritize more so than in other applications. For example, we're less concerned about uh, visual appeal or splashiness and more concerned with accurately and clearly representing patterns that we see in the data. We also generally want to minimize the amount of ink that we're using to convey a particular amount of information. And historically, scientific graphs were usually black and white because it was a lot more expensive to print graphics in color. This is still a concern today, but less so now that a lot of scientific publications are principally published online. One thing that we have to consider when publishing a scientific graph is the fact that we're often dealing with numbers that are very large or very small. If you have a number that has 20 digits, you probably don't want to print out that entire number. It would just take up far too much of the space available for your graph. So we use something called scientific notation to abbreviate long numbers. You can see some examples of that here. We would write the number 100 as 1 multiplied by 10 squared. A more realistic example is the number 15 million, which we would write as 1.5 times 10 to the power of 7. You can also see some examples here of how R would write the same number. Instead of using 10 to the power of a number, it uses the letter E followed by a plus followed by the exponent to represent the same thing. So if you were to create a ggplot graph with some large numbers, as you can see in this example, it would use this R version of scientific notation to display large numbers. Another consideration when creating scientific graphs is that we want to clearly label what's in those graphs. We can do so with ggplot by adding this labs function like you see here. It gets added on to the existing ggplot code just like a geom function does with the plus symbol. And then within the labs function, we can specify things like the X and Y axis labels, as well as a title for the graph. For axis labels, you usually want to label these with the name of the variable and any units if you have them. For titles, we can use something that quickly summarizes what's in the graph, such as, if we had a scatter plot, we could say it's a graph of the y variable versus the x variable, or maybe the y variable versus the x variable plus some additional context if needed to clarify this graph versus other graphs. If we only had one variable, such as in a histogram, we might just say the distribution of x or a histogram of x. We talked about minimizing ink, which basically means don't add extra features to your graph that aren't necessary. For example, if we just had a histogram of one variable like we have here, the default is just for it to be in black and white or shades of gray. We can certainly add a color like you see here, but that's unnecessary and it doesn't communicate any extra information. And in fact, it almost implies that there is some information there that there isn't, right? Because we can use color to distinguish between different categories. The other reason not to use colors is that often the default colors that you get if you just say yellow are pretty horrible, like the one you see here. If you do want to customize the appearance of the graphs, an easy way to do so with the ggplot graphs is to add a theme function, like you see in these two examples. Some of the good ones that are appropriate for scientific uses are theme classic, as in the top example, and theme minimal, as in the bottom example. And as you can see from the two histograms here, they remove a lot of the elements that are in the default ggplot. They get rid of the background color and different lines that are on the graph, such as the grid lines, or in this case, the axis lines. As with the labs function, we just add those to the existing graph code.